This is Geometry, Lesson 1-3, Part B. Our topic today is measuring segments. So let's finish up this lesson. It says when numerical expressions have the same value, you say that they are equal and you use the symbol equal. Now, we have another symbol in geometry that means a similar thing. It says if two segments have the same length, then we say that they are congruent segments. And we use the symbol congruent. And so basically it's an equal sign with this little swoop on top of it. Okay? And so here's the difference between when we would use equal and when we would use congruent. In this first set of segments, A, B, and C, D, we're told that they're both 1 inch. In that case, we know how long they are, and we know that they are both the 1 inch. And so then we would say that AB equals CD. Their measures are the same. Now, if you don't know what their measures are, you don't know how long they are, like in the second picture, all we know is this mark right here. And what this mark means when it's on a line segment like that, since they both have the same number of tick marks, it means that they are the same. They are congruent, but we don't actually know how long they are. We just know that they're congruent with the information we're given. That's when we would say that they are congruent. Now, when you use an equal sign, notice there's nothing above because you're talking about how long something is. But when you're talking about congruent, you put that segment above because I don't actually know how long they are. I just know that they're the same. So if you want to think about it, an equal sign doesn't have anything else above it, so neither should your names of your segments. But when you're talking about congruent, you have that extra swoop, so you want to have those extra measurements, those other extra segment bars above as well. Okay, so let's talk about this. It says, use the diagram to the right. Are segment AC and segment BD congruent? And then are segment AB and segment DE congruent? Well, if two things are equal, they are also congruent. So it would help to know how long these are, because if we know how long they are, we can determine if they're equal. So let's start with AC. AC goes from here to there. We want to find out the distance between them so we can go back to a previous knowledge of where we had the ruler postulated in this lesson and figure out how long that segment is. So AC is going to be equal to the absolute value of the difference of their coordinates. Well, A is at -2, C is in between 4 and 6, so it has to be 5. We solve that problem and we say that that is 7. Well, that's great, but it's not all that helpful if we don't have BD. So we're going to do the same thing now with BD. Here are your endpoints. Well, B is at 3 and D is at 10. We do the math. We should get to be 7. So AC and BD, they're both 7, which means they're both equal. And if they're both equal, they are the same. They are congruent. So the answer to this one would be yes. Pause the video now and do the next one on your own. You can see some of my work there. I got AB to be 5 and DE to be 4. Since those are not the same number, they are not congruent. They do not have the same length. Okay. Last slide. It says the midpoint of a segment is a point that divides the segment into two congruent segments. A point line or ray that goes through this point is also called the segment bisector. We're going to come back to this concept all year long. A midpoint, it is the middle. It is the middle of a segment. Now anything that goes through that midpoint of your segment is called the segment bisector. It could be a line, it could be a plane, it could be an array, it could be a segment. All of those could be your segment bisectors as long as they go through the midpoint of a segment. Where we use this are problems like this problem number 4. Oh, slid too much. It says using the midpoint. Q is the midpoint of segment PR. So if you look segment PR, Q is the midpoint. If Q is the midpoint, that means that PQ and QR are congruent, or they are equal. And so I like to put those little hash marks on there because those mean they're congruent, they're the same. So the question is, what are PQ, QR, and PR? Well, because we know that Q is the midpoint and PQ is then equal to QR, we can replace PQ and QR with these algebraic expressions that are above, 6x minus 7 and 5x plus 1. PQ is 6x minus 7, so we can plug that in. QR is 5x plus 1. And we can solve for x and then use x to find the length of these segments. So we want to start by getting all of our variables on one side and our constants on the other. So I would subtract 5x from both sides, add 7 to both sides. I get x equals 8. Now remember, this is geometry, not algebra, so it's great that x equals 8, but we're not done yet. We need to take that 8 and plug it back in. We get 6 times 8 minus 7, and 5 times 8 plus 1. So PQ is 6 times 8 minus 7. 6 times 8 is 48, minus 7 gives you 41. QR is 5 times 8 plus 1. 5 times 8 is 40, plus 1 gives you 41. Now, let's think about this for a second. Why did I do both problems? Did I need to solve for both PQ and QR at the end by plugging in that 8? Because we already knew that PQ equals QR. So if I knew that PQ was 41, I already knew what QR was. It's a good idea, however, to plug that 8 back in for both of the segments, if you can, because it checks your work. If I had gotten QR to be like 57, I made a mistake and I need to go back and find it. And so I would recommend plugging into both. It's your way of checking your work. So whenever I finish a problem, I always go back and read the directions. It says, what are PQ, QR, and PR? The reason being, I want to make sure that I answered all the questions. I found PQ, QR, but I haven't told them what PR is. The entire thing. Well, this goes back to the segment addition postulate. The sum of the parts is the whole. The parts are 41 and 41. So if I add those two up, I get the whole thing, which is 82. This next part kind of talks about what I already talked about. Is it necessary to substitute the value you found for x back into the expression to determine the length of the other segment? We said, not really, but it's a good way to show your work. All right, so this was Geometry Lesson 1-3. Remember, our topic was to find and compare lengths of segments.